Hello dear students, I hope you all are fine. You all are doing well in your studies and you all are enjoying and learning a lot through our videos. Students, so far in binomial theorem, we have studied about the introduction part which consisted of binomial theorem and its expansion. And we also studied about Pascal triangle. So students, now in this lecture, we are going to make some observations on the basis of the expansion of binomial theorem. And on the basis of these observations, we are going to solve some questions which are directly related to general term. But the question solving will be done in the subsequent lectures. Today, we will be more focused on the observations that are made in binomial expansion. So let's get started with today's lecture. Now let's move further with understanding some special cases. Alright, these special cases have been derived from the binomial expansion itself. As we all know that x plus y raised to the power n, binomial expansion of x plus y raised to the power n will be written as nc0 x raised to the power n y raised to the power 0 and so on. Alright, we have studied in our earlier classes of binomial that how to write the binomial expansion. Now, if I replace y by minus y, if I replace the variable y with minus y, so that replacement is going to be made in LHS as well as RHS. So what will be the change in LHS? In LHS, x plus y becomes x minus y raised to the power n. And in RHS, what will happen? First term will become nc0 x raised to the power n. This much part is not affected. Y raised to the power 0 becomes minus y raised to the power 0. So I think nothing is affected in the first term because minus y raised to the power 0 or y raised to the power 0 is going to give you the same quantity, that is 1. But what happens in the next term? In the next term, that is term number 2, t2, we will write nc1 x raised to the power n minus 1, and when y is replaced with minus y, this becomes minus y raised to the power 1. Alright, next term, let us now explore next term t3. It becomes nc2 x raised to the power n minus 2 and minus y raised to the power 2 and so on. This continues till last term, in which we are getting ncn x raised to the power 0 and minus y raised to the power. So you can observe or you can deduce that in case of second term, a minus sign will occur due to this minus y because its power is odd. Similarly, in fourth term, a minus sign will come out of the entire expression, right? So this can be written as nc0 x raised to the power n y raised to the power 0 minus nc1 x raised to the power n minus 1 y raised to the power 1 plus nc2 x raised to the power of n minus 2 and y square. Alright, because here minus y का square आप करेंगे या y का square आप करेंगे, so it is one and the same thing. But minus y raised to the power 3 and y raised to the power 3 differ by a minus sign. So the next term is going to be minus of nc3 x raised to the power n minus 3 y raised to the power 3 and so on. And last term becomes minus 1 raised to the power n ncn x raised to the power 0 and y raised to the power n. Well, this becomes the expansion of x minus y whole raised to the power n. So basically what we understood that in x minus y raised to the power n, only thing that differs from x plus y raised to the power n is that there is sign change from plus to minus, and that too not in each term. In fact, in alternate terms. Here minus, then again plus, then minus, then plus. So we will be getting a plus sign. First term will be with positive, second term will be with negative, third term will be with positive, fourth term will be with negative, and so on. Alright, so this is a special case of x plus y raised to the power n. Now if I am substituting x equals to 1 and y equals to x, so this expression becomes 1 plus x raised to the power n. Binomial becomes 1 plus x whole raised to the power n, and in RHS also you will have to replace x is equal to 1 and y with x. So what we are going to get is NC0, 1 raised to the power n and x raised to the power 0. Next term is NC1, 1 raised to the power n minus 1, x raised to the power 1, and so on up till last term NCn, 1 raised to the power 0 and x raised to the power n. So in short, I can write this as NC0 plus NC1x plus NC2x square plus and so on till NCn x raised to the power n, because 1 raised to the power any quantity, any finite quantity will be equal to, any real quantity let's say, will be equal to 1. Alright, and x raised to the power 0 over here will be equal to 1. Again this terms become 1 and x raised to the power 1 is written as x. So 1 plus x raised to the power n is equal to this expansion. You are supposed to memorize this expansion because it is more frequently used in many questions of binomial theorem. So 1 plus x raised to the power n has this expansion. Now in this expansion, if I substitute x equals to 1, if I substitute x equals to 1, so LHS becomes 1 plus 1 raised to the power n, and RHS becomes NC0 plus NC1 plus NC2 plus NC3 and so on till NCn. So here in RHS I have written, sum of all binomial coefficients. We have written sum of all the binomial coefficients, while in LHS it becomes 2 raised to the power n. So sum of all the binomial coefficients is equal to what? It is equal to 2 raised to the power n. And in terms of summation, I can write it down as sigma. I had told you about summation in earlier class. Sigma, this will be NCR, because the lower subscript is varying, it is the variable, so I have written over here as R. Upper subscript is always n, so here I have maintained n, and R is varying from 0 to n, and we are adding up all this term. That is why I have used the operator sigma of summation. So summation NCR, where R lies from 0 to n, will always give you 2 raised to the power n. So students, you are supposed to memorize this result which we have derived from the expansion of 1 plus x raised to the power n. That is sigma NCR, where R is lying from 0 to n, is equal to 2 raised to the power n, and it is sum of all the binomial coefficients. Alright, I hope सभी को समझ में आ रहा है. चलिए, if now I substitute x equals to -1, अगर अब हम x की जगह पर -1 रख दें, then LHS will be 1 minus 1, and 1 minus 1 raised to the power n will be 0, and RHS is going to be NC0 minus NC1 plus NC2 minus NC3 and so on till -1 raised to the power n, NCn. So you can memorize that NC0 minus NC1 plus NC2. If binomial coefficients are written down with alternative plus minus sign, then their sum comes out to be 0 if all the binomial coefficients are included. Alright, so in 1 plus x raised to the power n only, when we have substituted x is equal to 1, we get the summation as 2 raised to the power n. When we substituted x is equal to -1, we get the result equals to 0. Alright, now it is very obvious that 1 minus x raised to the power n will have expansion as NC0 minus NC1x plus nc2 x square minus nc3 x cube. I hope everybody will be able to write down now, because we have practiced it at least this much that we can write easily the expansion of 1 minus x raised to the power n. So the last term is going to be minus 1 raised to the power n, because there is a confusion in last term whether it will be with plus sign or minus sign. It depends on n. That is why I have written minus 1 raised to the power n, and coefficient will be, binomial coefficient will be ncn and x raised to the power n. So this is the binomial expansion of 1 minus x raised to the power n. So these are some of the special cases which we deduced from which series expansion? X plus y raised to the power n. Alright, I hope सभी को समझ में आ गया. Everybody is getting till this point. So let's move forward. Okay students, now just for your practice, let us consider an example. Suppose we have to write down the expansion of x square plus 3 by x whole raised to the power 4. Here x is non-zero. Alright, so you have to write down the expansion of this binomial. This is definitely a binomial in which a की जगह पे we have written x square, and in place of b we have written this entire term, that is 3 by x, along with a addition sign in between, plus sign in between, and the value of n over here is 4. So the expansion is going to be, first term is 4c0 x square की पावर में 4 minus 0 and 3 by x की पावर में 0. Alright, I hope everybody is getting. We have written nc0 a raised to the power n minus 0 and b raised to the power 0. Alright, now next term will be 4c1. Next term will be 4c1 x square की पावर में 4 minus 1 and 3 by x raised to the power 1. Next term will be 4c2 x square raised to the power 4 minus 2, that is 2, and 3 by x raised to the power 2. Next is 4c3 x square raised to the power 4 minus 3, that is 1, and 3 by x raised to the power 3. And finally, last term will be 4c4 x square raised to the power 0 and 3 by x raised to the power 4. Alright, now if you want, if it is the demand of question, you can also elaborate it. So 4c0 will be 1. If you are not memorizing it, you will have to calculate 4c0 using the formula of NCR, that is n factorial divided by n minus r factorial into r factorial. Let me write NCR is equal to n factorial divided by n minus r factorial into r factorial. We have covered NCR in the chapter called permutation in combination. Alright, so 4c0 will be equal to what? 1 multiplied by x square raised to the power 4 will become x raised to power 8, and this terms becomes 1. So first term is x की power 8. Now 4c1 is equal to what? 4. x square की power में 3 gives us x की power में 6. 2 raised to the power 3 implies 2 multiplied by 3 and gives us power as 6, and 3 by x raised to the power 1 can be written as it is. Now this x gets cancelled off with x raised to the power 6, leaving x raised to the power 5. Alright, so the second terms becomes 4 into 3, that is 12x raised to the power 5. So this is what I am trying to say. If you want to elaborate, if you want to write each term in detail, you can do it. You have to perform the calculations. 4c2 becomes 6, this becomes x raised to the power 4, and here x square. So x square get cancelled off in numerator and denominator, and you are left with what? You are left with x square. So this is 6 into x square into 9, which is 54x square. So this is going to be your third term. Similarly, you can calculate this term. 4c3 is nothing but 4. Alright, 4c3 is as good as 4c1. X square raised to the power 1 is x square. 3 ka cube is 27 divided by x cube. So this becomes 27 into 4 divided by x. Alright, this is 8108 divided by x. Alright, last term is 4c4. 4c4 is nothing but 1, and x square raised to the power 0 is 1, and 3 raised to the power 4 is 81 divided by x ki power 4. So this is the last term. Let me highlight. This is first term, this is second term, this is third term, this is fourth term, and this one is going to be fifth term in the binomial expansion of x square plus 3 by x raised to the power 4. Alright, I hope everyone must have understood this example. Now let's do a question which is based on the logic of binomial. Question says, which is larger? Which quantity is larger between 1.01 raised to the power 10, 20, 3, 4, 5 and 6. Alright, so basically 1.01 raised to the power of 10 ki power 6, and the another number is 10, 20, 30, 40. Alright, so here I have written 1.01 raised to the power of this number and then 10,000. Out of these two quantities, which one is larger? Alright, 1.01 raised to the power 10 lakh or 10,000. Now one must be thinking of approximation and guessing the answer that this quantity is almost equal to 1. So when 1 is raised to the any power, this is going to give us an answer which is almost equal to 1, but this one is 10,000. So if you are calculating or guessing it in this way, then I must say that this is wrong approach. Alright, do not underestimate 1.01 raised to the power 10 lakh as a smaller quantity. Let me tell you with the help of binomial. 1.01 will be written as 1 plus 0.01 raised to the power 10 raised to the power 6. Alright, here we have 1, 2, 3, 4, 5 and 6 zeros. That is why I have written this number as 10 raised to the power 6. So n becomes 10 raised to the power 6. If we take it as a binomial, this is a, this is b and this is n. So basically we have to write down the binomial expansion of 1.01, 1 plus 0.01 raised to the power 10 ki power 6. Now don't worry, you don't have to write each and every term. Just write 2 to 3 terms in order to get the idea. So first term is going to be NC0, NC0. 1 raised to the power anything will be 1 only, and 0.01 raised to the power 0. Alright, next term will be 10 ki power 6 C1 NC1, and now I am not writing in, we are not interested in this part. In fact, we are only interested in this part. So this becomes 0.01 raised to the power 1. You can directly use the expansion of 1 plus x raised to the power n. If you remember, this is NC0 plus NC1x plus NC2x square. Alright, so the next term will be 10 ki power 6 C2, and along with it, with this we will have, let me keep it in bracket if it confuses you. Along with this, we are going to have 0.01 raised to the power 2. Alright, and next term will be 10 raised to the power 6 C3 and 0.01 raised to the power 3. Alright, and so on. So we have written down some terms of binomial expansion of 1 plus 0.01 raised to the power 10 ki power 6. Let us calculate. The first term is going to be, see, NC0. I have told you that NC0 is nothing but 1. over here. NC0 is always equal to 1. So this is 1, this becomes 1. 1 raised to the power any finite quantity or real quantity, this is also 1. And 0.01 raised to the power 0, this is also equal to 1. So first term is equal to what? 1. Now let's move to second term. Second term is 10 raised to the power 6 C1. Second term is what? 10 raised to the power 6 C1. So this is following NC1. NC1 is equal to what? N. I have written over here and I have asked you to please memorize it so that it can save our time. So second terms, 10C6 C1 becomes 10 raised to the power 6. Alright, 0.01 raised to the power 1 means 1 by 100, which is 10 raised to the power minus 2. Next term is 10 raised to the power 6 C2. Now I am not writing next terms, I am just showing them by dots or dash. Let me see the calculation. This is 1. 10 raised to the power 6 multiplied by 10 raised to the power minus 2. This becomes what? 10 raised to the power 4. Alright, and 10 raised to the power 4 implies 10,000. So I think the question is solved. In the expansion of this 1.01 raised to the power 10 lakh, we have seen that this is equal to 10,000 plus 1 plus some positive quantities, because we know that all the other terms coming over here in the binomial expansion are going to be positive. So this is positive, this is positive, this is positive, and this is 10 raised to the power 4. And we had to compare this number, with 10 raised to the power 4 itself. Alright, so when we expand 1.01 raised to the power 10 ki power 6, we are getting it equal to 10 ki power 4 plus 1 plus some positive quantity. So what do you think? Which quantity becomes larger? Obviously, the quantity that has been written on left hand side, that is 1.01 raised to the power 10 lakh. This quantity is greater than 10,000. If you had made a rough guess, then you would have ended up making a blunder of approximating it to 1 while RHS was 10,000. So you might have got an incorrect answer. While with the help of binomial, we have concluded that which quantity is larger? 1.01 raised to the power 10 ki power 6 is greater than 10,000. Alright, this is the binomial theorem. This is the beauty of binomial theorem. So please don't make rough guesses. Try to think analytically. Alright, so now I am giving you some very small questions so that you can attempt them on your own. You have to write down the expansion of. You are supposed to attempt them on your own. These are just for your practice. 1 minus 2x raised to the power 5. You have to write down the expansion of this. How many terms will be there? There will be 6 terms in its expansion. Then 2 by x minus x by 2 raised to the power 5. Again, how many expansion will be there? How many terms will be there in this expansion? Again, we will be having 6 terms. Alright, and you can take a more. 3x plus 2 upon x cube raised to the power 6. How many terms will be there? There will be 7 terms in this expansion. Alright, so just try to do these problems for your practice on your own. And today we learned about some special cases, alright, and some results, and on the basis of which we did a few examples. We will be continuing our next class, alright, and I will be taking the theory further along with some questions that are based on binomial theorem and general term. First we will be doing questions and then I will take the theory further. That's it for today's class.